Hi and welcome back. Today we're going to talk about pointers, particularly through the lens of the C programming language, but the concepts we're covering today should help you understand how more languages work. A lot of languages have pointers, they deal with them in their own way, but under the hood, the idea of what a pointer is doing is the same. Pointers are often difficult to understand initially, so if you're not picking this up very quickly, that's okay. Feel free to watch the video as many times as you want, or to look up some companion graphics, or even to check out, believe it or not, the Wikipedia page on programming pointers is very good. So let's hop into this today. We have this basic program here that's going to help us understand how a pointer works, but first I need to set up an image in our minds real quickly. So imagine you're visiting a friend's house. They have a wonderful kitchen, restaurant class kitchen. Everything has its place, and there's a very large island countertop in the middle that's empty, right? In order to start cooking, first you have to get your ingredients out. You have to set them on the counter. Right, you have to get any tools you're using, if you need knives or cutting boards or maybe a pan to start setting up the food before you then take it to the stove or oven to make. And you need whatever recipe you're going to follow. There's a lot of things you need that take up space on this countertop, right? So keep this image in your mind throughout our video today. I'm going to reference back to it a few times. So our programs are very similar to a kitchen like this. Our computers are, where we have all these resources in our hard drive and our programs, or data that comes in from the user, data that comes in from the internet, right? We have all these places we can get things from to then do operations with and change things. Maybe there's a food processor in the kitchen, right? Maybe there's another program on our computer we're using, kind of the same thing there. And they all have a place they take up. But in order to use them, we have to know how to get to them, right? If it's just a big pile on the counter and nothing's organized, you're not going to be able to find anything in that counter, or a spice rack without organization. In this program, right, when we declare a variable x of the type int, or an integer, we are telling the computer, I need space that's one integer wide, okay? Let me know what the memory address is for that, the location in the kitchen or the countertop for it, right? Give it back to me, and we'll make this little variable so I know how to get back to it, okay? And while we're at it, in that location we just set up, put the value 12, right? I'll come back to it later, right? I'm a variable. And then we do the same thing for y, right? And even though x and y both have 12 in them, they're in different locations, right? You can have eggs in the fridge and eggs on the counter. You know what I mean? There's two different locations, even though they're the same thing. Now, we'll notice that this next line should look new to us. And this line is how we create a pointer. So the first big difference, you'll notice there's an asterisk here. There's not usually an asterisk when we declare an integer. This is how we want a pointer, which is something that holds the memory location, a map back to wherever we stored, say, this 12, because in this case, we're going to be making a pointer of x. We'll talk about that ampersand there in a moment. And we're going to copy the memory location. We're going to give it a name, right? So give me space to store the map, the address, the reference to whatever variable. In this case, we're going to say x. This ampersand is the fancy, I don't actually know exactly what you'd call it, but it's the way we access the memory location, the address. So when we put this ampersand before x, instead of assigning pointer of x the value of x, which is 12, we're giving it the location of x, which is some memory address, right? Instead of saying, this is like, instead of handing someone the coriander, saying the coriander is on the third shelf, 3 bottles back on the far left, right? That's how you get to it. So then instead of you handing them the coriander, they know how to get to the coriander. In the scope of this function, This is pretty extra because we can already access x. We don't necessarily need a pointer, but I'm doing this to demonstrate how it works initially, and then we'll move on to another simple program that uses pointers a little more effectively. But again, just a quick recap, we have the actual data in its location through its variable, and then the memory location or address of x, right? So pointer of x is going to contain, address 103.224.777, whatever the computer decides when we declare our variable, right? And so that location is going to be sent here. So if we just access x, pointer of x, as a normal variable like we would for x or y, we're going to get the address location. But if we use the ampersand on a normal variable, we also get the address location. So we have the path to get back to it. Now, how do we get to the 12 when we know how to get there, right? How do we tell the computer to do that? We'll cover that in just a moment, but keep that question in the back of your mind. So right here, we're just going to print out, that our variable is named x. What's the value? Well, we're going to do the value that's x, right? What's the address? We're going to do the address of x. And we're going to do the same thing with y and the address of y, right? And then down here, we're going to do the same thing with pointer of x and the same thing with address of pointer of x, right? So I've already compiled this ahead of time. So we're going to go ahead and run our basics program. And you'll see here, we expected x to be 12, right? We assigned x to 12, and the address ends in 692. Y, we also expect to be 12, right? But the address is different. It ends in 688, right? Same value, different address. Eggs on the counter, eggs in the fridge. Same thing, different places. So it's two different copies of the same information. Now our pointer, I'm just using the star because that's oftentimes how that's actually how you access a pointer, which is the answer to that question I asked earlier, and I'll show you more of that in a moment. But you'll see the value stored inside of x when we access it like we did y or x. So in pointer of x is the same as the address of x, just like we were saying. That's what we expect, right? And the address is something different, ends in 680 instead of 688 or 692. So it's in a different spot of memory because that memory is holding the value of our address. Not the value in the address, but the address itself, right? So if we wanted to change this program to see the value we have stored at x, right, this integer here, by using our little map, our referenced value, what we do is we put a star in front of it, an asterisk. That's saying we're going to access this pointer, right? And we're looking at the address of pointer of x, right? And we already know that, let's make it so that we're looking at where that data lives that we're pointing to, which is actually going to be the memory address of x, which is the same thing as running this, right? So let's save that. Let's compile that. Now these warnings are nothing you need to worry about. I'm just accessing the address value in a funny way to display it, just because it's a little easier for demonstration's sake. But if we run our basics program, we'll see now we're seeing the data that exists at that address, right? So imagine you had multiple functions. This is where it becomes useful. Imagine you have functions or methods that need data to be passed between them, but you don't want to be passing copies of the data. You want to make sure it has access to the actual data. You can use a pointer, right? You can even use pointers to pass references to functions or arrays. If anything exists in memory, it can be accessed with a pointer. Creating the pointer become more complex as your data types become more complex, but they're entirely possible to create and use. So we're going to move on to a more robust program, still a very simple program that shows us how we can use pointers, not just what they are. So you'll notice we have our main function and we have an add function, okay? This add function doesn't return anything. It returns void. but it takes two integers and the pointer to an integer. It adds those two integers together. See, you're going to see that here. It adds number 1 and number 2 together. And then it assigns it to the dereferenced result value, right? Remember, result's a pointer. So if we got rid of this, that means we're reassigning our little stored integer pointer memory address to be number 1 plus number 2, not wherever this location is. So we have to dereference it with the star to make sure the data ends up back to the original location we made the pointer to. Okay? And then what we're going to do here is we're going to print out the value of this memory address before we do anything to it. We're going to print it out after we do anything to it, right? So in our main function, we are going to create just an integer variable answer with, in this case, it's just going to be some garbage data, 1, 2, 3, 4, 5, 6, just to show that there's something there living in the memory space, right? We're going to print out that 1, 2, 3, 4, 5, 6 actually exists there. See, we're not doing any dereferencing. We're just accessing the variable. Then we're going to call our add function. We're going to add 12 plus 12, and we're going to pass it the memory address or the location or this is almost a pointer, but in this case it's the address of answer, right? And then through actually declaring these local variables that are going to happen within our function, we create the pointer here, right? So we really are creating the pointer by passing the memory address, just we're not doing all the syntax in one place. And then we're going to run that. It'll do the math. It should, right, assign it to the location of answer, right, because we're dereferencing. So results has a map. We follow the map. The star is telling us to follow the map back to answers, and we're going to overwrite that data with whatever 12 plus 12 is, so 24. Then we're going to print out those answers. We'll get to this part in a moment. So let's go ahead and we will run our pointers program, and we'll see that it does what we expect. Our initial value, 1, 2, 3, 4, 5, 6, just like we set up here. Then it's going to read our pointer value, 1, 2, 3, 4, 5, 6, within our function. So we know we're accessing the right data, right? And we can see that. Then after we've done our math step here, it's going to return 24 to the same results location, right? And then once we get outside of our function, so once we exit the scope of this results variable and it disappears, right? You know, it gets dropped from our memory because we're not using it anymore. Here we access answer and we see it's still 24. So we changed a variable outside of its scope because we passed the memory address. So we were able to access the data still. So we didn't need to make a copy. We didn't need to return anything. We changed live data. Now, usually for an add function, you'd want to return an integer instead of using a pointer. But you can do it with a pointer. And there's a lot of things that make more sense to do with a pointer. Say you're modifying a list or arrays. You know, there's lots of things you can do with them, including actually passing functions, which is the next thing we're going to do. We're going to take a look at this chunk of code here. Let me uncomment it. This shows us how to make a pointer to a function, right? So you'll notice this first line, number 16, looks really similar to the line where we declare our add function, right? You know, we have the name of our function, which in this case is the pointer to a function, right? Remember how we declared pointers initially with our star? It's the pointer to a function with a void return type, and these are the three kind of arguments it takes. It takes an integer, and the pointer to an integer. So we set up the blueprint. Then we're going to, just like we did here, we're going to pass the memory address of our add function and assign hello to be that function. So, and then immediately after that, we can call hello, and it will behave the same as add. Off the cuff, this probably seems like a really dumb thing. Why don't you just name the function what you want it to be? But think much bigger. Think when you're dealing with complicated scopes, or you say build a function, right? Let's say we made a function that then created its own function and passed that function back out to be used. Like let's say we wanted to create an add function that took no arguments, right? But added numbers that the user set. So we could create a function that took all of the same arguments, right? But instead of actually doing this, it returned a function that did that. It's complicated to do, but you can do that. And then we're going to go ahead and just print that data out just like we did before. So if I recompile our program, you're going to see we have a few extra lines here. But these bottom three are the ones that we just changed. So now you'll notice we passed that same memory location in, right? We passed answer, just like we did before. And we see that the previous value was 24, right? Makes sense. That's what we expected. And then we made our change. It reassigned it to 135, and then outside of the scope of our hello function this time, which points to where our add function is. So it's the same operations happening, but it's a different function itself, of a different name. It's been declared differently. We got the same data. So that's kind of the basics of how pointers work. There's a lot more to them. There's a lot to read up on. But hopefully now you have a surface level understanding of what a pointer is and a few ways you can use them.